Hello, I'll be demonstrating Lucene in this tutorial. So Lucene is a simple Java-based search library. It can be used in application to add search capabilities to it. Lucene is an open source project. It is scalable and high performing library used to index and search virtually any kind of text. So let's get started. I have created a Java project and I have added this Lucene code 3.6.2 jar in it. It's the only required jar to be added externally. So first I have created this constants file which has some constant which we'll be using in our project. Now this is the text file filter class. The role of this class is to validate if the file that is present in the correct directory should be included in our indexing or not. So in this case we are just indexing the .txt files. So this except method will return true if the file extension is .txt and will return false if otherwise. Now moving on to the next method, this is the index writer method. Index writer is a class which takes the file as input and indexes them. We use these indexes later on in Lucene library for searching purposes. This indexer is a constructor for the class. It takes as input the index directory path, sets the directory and create an index writer. We use this constructor which has the directory as the first argument, the analyzer as the second, and the true is a boolean which stands for creating this directory, and this index writer dot max field length dot unlimited is the max field length of the index writer. Now this get document method takes in file as an argument and checks and creates Lucene documents which has three main attributes, which are the content field, the file name field, and the file path field. In this case we'll be searching for only the contents of the file. So for the file name field and the file path field we are setting the index to not analyze. So this will not analyze the file name field and the file path field. And now this index file is actually creating an index document. We now come to this create index method. It takes in input the path of the directory from which we are taking the files and the file filter that we created. It will traverse one file at a time and will create indexes if it passes the file filter that we just created, and in the end it returns the number of docs that it created. Now moving to the searcher class. This class does search on the indexes created by the indexer. This class will return the path of the file which has the desired keyword that we are looking for. The index searcher reads the indexes that we created in the index classes. The query parser class passes the user entered input to Lucene understandable search queries, and this query is a simple query object. Moving on to the methods. This searcher method takes the path where the indexes have been made as the input. We open this file directory and pass the directory to the index searcher. We then initialize the query parser object here in the searcher method, and since we will be searching for the file contents, we are using Lucene constant contents that we declared earlier in the Lucene constant file. The actual searching now happens in this search method, which takes the input search query, which is generally the item that we are searching for. We now use query parser to create the query and then return the result using index searcher. Here the max search restricts the maximum number of results, which in our case is 10. Now for every search that we make, the Lucene returns a doc score, which is a measure of how relevant the search is. It is influenced by factors like term frequency, inverse document frequency, and number of terms in the query that we found extra. So this get document score method returns the score of the document. Now we move to the Lucene tester class, which contains the main method for our execution. The index directory contains the path in which the indexes will be made. The data directory has all the files on which the searching is to be done. We create a indexer object and a searcher object. Now in main method we are searching for the keyword Sadashiv. Now, in this case, we are using these 10 records for searching the data. As you can see in this particular folder that I mentioned here, I have a file called Sadashiv which has Sadashiv as a content in it, but the extension of this file is .doc, so this file will not be included in the final result, and these three files contains Sadashiv in it, so this record 1, record 3 and record 4 should be the final result of the search. Now first, in this main method we call the create index method. In this create index method, we create instance of the indexer and pass it the data directory, that is the path of the directory in which the files are, and the text file filter that we created. Here we will note down the time it takes to create indexes on the files. Now after that we will call the search method, which will search for the query Sadashiv in all these documents. In this search method, as we can see, we have created an instance of this searcher class and we pass the index directory to it. This will call the default constructor and the indexes will be accessed from this path in that class. So when we call the search method and pass it the search parameter, that is Sadashiv, it will return us the hits. Hits will be the documents in which the keyword Sadashiv will be there. So when we traverse the score docs in this hit, we can print out the file path of the files that contains the word Sadashiv. Now it's time to run the program. So as you can see, it took 148 milliseconds to pass those 10 documents, and as you can see there is no document here, and the result was found in 3 documents: record 1, record 3 and record 4. Record 1, record 3 and record 4. So that's it for this tutorial. Bye bye.